All right, so in this video we are going to go over the odd problems on the homework multiplying and dividing rational expressions assignment. Remember, this is just a quick video. It's not an instructional video. You should watch those first before you watch these videos. So first we're going to find the excluded values, or sometimes you'll see the word restrictions. I use the word restrictions. And this is basically what can our variables not equal. We only want to do this after the bottom part is factored, but we're going to take each variable and we're simply going to set it not equal to 0. So our two variables at the bottom in this problem are x and y. Neither one of those can equal 0 because, of course, if they were, we would be dividing by 0, and that gives us an undefined answer. So the restrictions part is done. Now we're going to do the simplify part of the problem, which ultimately is worth more points on most of these problems. So we want to factor the top. The bottom can't be factored. So the top, I notice there is a greatest common factor. I believe it is 6. 6 goes into 12, 6 and negative 24. They all have at least one x in common, and they all have at least one y in common. And that's going to leave us on the inside of the parentheses 2x to the 4th. Erase this one. Plus x squared plus y minus 4y. So that's the top part of our problem factored. The bottom half of this problem is just still 3xy. And at this point comes kind of the fun part. You're just going to cancel out any common factors. So the y's here will cancel. The x's will cancel. The 6 over 3 reduces to 2 over 1. So our answer is 2, parentheses, nothing canceled on the inside. So you cannot cancel out across addition or subtraction. So that's why none of these x's on the inside canceled out. It's all technically over 1, but anything divided by 1 is itself. So that's as far as we can go. Skipping question 2, number 3. So number 3 is multiplication. Again, we are stating excluded values. We need to factor everything first. Top left doesn't factor. Bottom right, I'm going to skip the work for this part because you should know how to factor the bottom right. We're looking for two numbers that multiply together to give us negative 16 and add together to give us positive 6. So that's 8 and negative 2. The top right factors into x plus 1 and x plus 8. And the bottom right, x plus 3, x plus 4. So again, at this point, we want to do restrictions before we cancel, but after we factor the bottoms. So to get the restrictions, we're going to take each factor that has a variable in it, and we're going to set it not equal to 0. So that's our first factor. If we solve that for x, we subtract 8 from both sides. X cannot equal negative 8. So that's one restriction. And then I see an x minus 2. I'm going to set it not equal to 0. Solve for x. There's my second restriction. So we're just taking each one of these bottom factors and setting it not equal to 0, and then solving for x. Again, these factors, or these values for x, would give us a 0 at the bottom of the fraction, and you cannot divide by 0. Some people say, oh, it's just the opposite of what you see at the bottom. And that's the case in a lot of these, but if you have something like a 2x plus 3 at the bottom, that little trick does not work. So that's why I always solve them for x. Then what I like to do when it's a multiplication problem, treat it basically as one big fraction, because ultimately all we're doing is multiplying the tops and multiplying the bottoms. But before we do that, we want to cancel out like factors. So I see there's an x plus 3 at the top, and there's an x plus 3 at the bottom. Those cancel. I see an x plus 8 at the top and an x plus 8 at the bottom. Those cancel. No other common factors, so your answer is whatever's left over. X plus 1 at the top, x minus 2, x plus 4 at the bottom. Number 5 is a division problem. So before we factor before we list restrictions, we want to change this to a multiplication problem and flip the second fraction, because of course we are dividing. So when you divide, you multiply by the reciprocal of the second fraction. So notice it's only the second fraction that changes. It gets flipped. I'm going to mark out this original problem. And basically this is the new problem. Just like question number 3 at this point. Now it's multiplication. So now we factor everything and then list our restrictions. So the top left, v plus 2, v plus 5. Bottom left does not factor. Top right, so we can pull a 6 out. GCF of a 6. And then bottom right, it's a trinomial. So that will be v minus 3, v plus 2. Be careful on that one. So now we're going to list our restrictions. I'm going to set all of the bottom factors not equal to 0 and solve for, in this case, the not equals. And do the same thing for the others. So there's all of our restrictions. Now we can do the fun part. We just start canceling out common terms. So I see v plus 2 at the top. And we'll treat this basically as one big fraction. V plus 2 at the bottom. Those cancel. What else cancels? The v plus 6 and the v plus 6. Notice this 6 cannot cancel with this 6. That's, of course, because that 6 is kind of attached to the v because of that plus sign. So our answer is everything left over. You got a 6, you got a v plus 5 at the top, and you got a v minus 3 at the bottom. The v's don't cancel because, again, you cannot cancel across addition and subtraction. All right, and finally, number 7. I'm going to go ahead and factor and do the multiplication flip trick kind of all at once on this one. So factor the top, that's x plus 10, x minus 10, that's perfect squares. Factor the bottom, two numbers that multiply together to give you 4 and add together to give you -5. It's -4, -1. Division problem, so I'm going to change it to multiplication. And flip the second fraction. So top right is x plus 4, x plus 3. We're multiplying by the reciprocal. And then x plus 10, of course, does not cancel. So first we're going to list the restrictions. So it set each bottom factor not equal to 0. So there's our restrictions. And then we're going to cancel out any like factors. I'm not seeing many. I see an x plus 10 at the top. And I see an x plus 10 at the bottom. The x plus 4 and the x minus 4 do not cancel out because they're not exactly the same. Those are actually two completely different numbers if you think about it. So nothing else cancels. So we're just going to multiply the tops. When we say multiply the tops, we just set it up for multiplication. We don't actually have to go through the process. And that's our final answer.